In the previous lesson, we did an overview of the entire Ton ecosystem. Now we're going to dive specifically into the architecture of the blockchain itself. So, what's the block and what is the chain in the context of blockchain? Ton is a ledger of state transitions. It's kind of a more general idea than just a ledger of transfers. It's a ledger of changes in the state of arbitrary accounts. Every smart contract is also called an account. And an account has its own storage and it has its own unique address. Accounts also store the balance of Ton coins and the program code. And it's up to the developer to design the logic of the contract by using any code they want within the syntax supported by the virtual machine that's called TVM. Developers are provided with pretty much unlimited flexibility through the lifetime of the contract. They can change the data, and they can even change the code of the contract. And they can transfer the coins around and send messages to other contracts. And it's important to note that these contracts are self-contained. They have no visibility into anything outside themselves. This is what ensures the infinite scalability of the Ton blockchain, as every contract is isolated from the others. It can only receive the incoming message from some other contract or from the outside world, and then it can process this message by its program code, change its own state, save the new data, and create the outgoing messages to other contracts. As Ton blockchain is asynchronous, it cannot go and read the state of any other contract and immediately get the result. In order to use some other contract state, the contract has to send an outgoing message, and maybe later it will receive the desired reply. This concept makes these contracts look very similar to computers on the internet. Like every computer is independent, they have their own data, they are programmed separately, and they have no idea when and how their messages will be processed by others. There are some guarantees that the blockchain provides to you as a developer. You could verify the address of any incoming message and be sure that behind this address there is a specific code that you may trust. And similarly, if you're sending the message to an address, you have a cryptographic assurance about the code that is behind this address. The network guarantees that the message will be delivered, but it doesn't guarantee how long this will take. The chain of messages could span thousands of shards and take multiple blocks to finalize the transaction. It may also be a case that some intermediate contracts run out of money and fail processing their messages. So, when you develop your contract, you need to focus on your own contract's consistency and the way it interacts with other contracts and handle all the possible scenarios. So what are messages and what are transactions? The thing that happens in between two contracts is called a message. It carries a little bit of coins and arbitrary data to a contract address. When the message arrives to the contract, it is processed by the contract's code, the contract updates its state, and emits new messages. All this activity on a contract is recorded as a transaction. Think of this if you have a chain of messages from contract A to contract B to contract C, then you have a message in between A and B, but you have transactions on A, a transaction on B, and then you have another message from B to C, and the second message, and the third transaction is recorded on account C. So if you have this chain with two messages, then you have three transactions and two messages. The blockchain itself is just a data structure. To change it, there must be a signal from outside. The user presses a button in the wallet creates an external message to a destination contract. The wallet sends the message to the validators who apply it to the contract. So in our previous diagram, we need a third message that is an external. And the users typically send the messages to their own wallet contracts that record these as the first transactions. And this first transaction typically contains the embedded message to the actual destination contract. And then when the wallet contract receives this message, they process it and deliver it to the destination contract. So you can see that every contract has its own transactions, which means that every contract has its own little blockchain. And this is quite helpful because the network can then process and verify transactions completely independently from each other. The only question remains, how do you route these messages and how do you prevent double spends. So let's start with double spends first. I can send money to a person A, or I can send money to a person B, and either of those are two completely valid transactions. And from the perspective of the entire network, it doesn't really matter which one is recorded as long as it's the only one. And for this, we need consensus. To make consensus scale horizontally, Ton uses proof of stake, where you have a set of validators that put a large amount of Ton coins as a security deposit, or as a security bond that guarantees that they don't misbehave. If any validator misbehaves or is switched off, they are punished with the small or big fines that are taken out of this bond. In Ton, the set of validators can be sharded. If the load on the system increases and the number of accounts grows, then the sets of validators could be split in subgroups. For instance, even account numbers could be handled by one group, and odd account numbers could be handled by another. Ton allows this sharding to be pretty much unlimited down to individual contracts, depending on the load. When all the validator groups achieve agreement on their parts of the blockchain, they record the state of the accounts on a central non-shardable blockchain called master chain, where every validator participates. So in Ton, you have this kind of two-tier system. You have the master chain, and you have this base chain. The base chain is the one that is kind of virtual, because it actually contains all of these various accounts that could be sharded infinitely down to each individual account and could be split and merged into the shard chains. And the master chain is not shardable, and it is expensive in terms of fees, and it doesn't scale. But it is a load chain that contains only the configuration of the network and snapshots of all these subchains from various validator groups. So this is the picture of the blockchain. And this explains the latency in transaction processing. So when you process a transaction on the blockchain, this takes around 5 to 6 seconds to be committed at the first hop. And then it takes 5 to 6 seconds to do the same commitment into the master chain. So the total delay to make a globally visible commitment to a single transaction would take around 10 to 12 seconds. And this is just for the initial transaction. Then, if the transaction creates a long chain of messages, those could be routed, and sometimes they could go in a single block, sometimes they could span multiple shards or separate blocks. So if you're only interested in the final transaction, then they could take much longer. However, in typical scenarios, the chains of messages are quite short, and you also often don't have to worry about committing and waiting for the commitment of the last one, because once the first transaction is recorded, you may often predict the results of all the subsequent transactions. For instance, when accepting simple payments with tokens, you may detect the confirmation of the initial transaction performed by the user, and not worry about the funds arriving at your destination wallet, which could take 4 individual transactions. To conclude, in Ton, each contract is its own account with data and code. Contracts are isolated from each other and communicate by sending messages. This allows blockchain to be infinitely sharded. Consensus of validators guarantees that messages are eventually delivered, they are not replayed, and funds are not double spent. And finally, most operations take multiple transactions over a number of contracts, but it takes only seconds to confirm the very first transaction. And this is the overview of the lesson 2. Thank you.